That might have been our time to start the meeting sound.
Wonder if Daniel is aware that it has open mic. Or if you should mute him. Which I guess it's work for Gory then. Ah, he muted himself. Good.
Mm-hmm. Okay. Gory, you ready to start?
Audio from Gory.
Okay, I think I can make this work outside of slideshow mode, so that'll give me some access to Meet Echo. All right, folks, we ready to go?
Apparently lost Gory. So
Yeah, everybody's apparently on mute at the moment. Gory, well, let's see, Gory says is offline. Wes, are you there? Make that 2 working group chairs offline. All right. I guess I need to go ahead and get this started. There's Gory. Hang on.
looking at the Jabber chat, I think Miteko might have some small issue because it seemed it dumped quite a lot of users. And that's...
Yeah, it looks like my show. Okay. No end of fun. Gory, are you there? You just muted yourself. Try again.
Okay, I'm not muted. Okay, I am here now. A long bit left.
Yeah, it's just wonderful. It's very easy to double mute yourself, and then you have to left meta shift click to figure out how to get out of it. All right. I think I've got things set up. There's enough, the slide's big enough. I think people can see it, so I can probably toggle back and forth between windows, and we'll try to make that work. All right. Welcome to the Transport Area Working Group meeting at IETF 110 online. All 3 of your working group chairs are here. We're all remote. This is the Note Well reminder that as part of registering for the meeting, you agreed to this. This applies to you. All kinds of references there, which I will not go through. Okay. Do we have a lead note taker? we need somebody to
I was planning on taking some notes.
Okay. And if you could start by pasting the agenda in, that tends to work really, really well, Wes. All right. Let's do that. I mean, we don't need the blow-by-blows. I suspect most people don't read the minutes for blow-by-blow. We do need to record any major decisions that get read. Okay. Need some people to watch Jabber. All you need to do is if you've got your eyes on Jabber and you see something turn up in the chat, raise your hand, and with luck, one of us will notice, and we'll get somebody on. We'll get you or whoever's making the comment in Jabber onto the mic. As usual, we always need reviewers for our working group drafts. And a reminder, folks, please do add Tsvwg to the name of any internet draft submitted. That way we might actually notice them. Okay, some Meet Echo usage tips. Both the chat and the meeting notes can be separated into separate windows or tabs. It's actually quite useful because it means that you can toggle back and forth between windows on your screen to change context as opposed to having to find the right icon in Meet Echo, and it leaves your Meet Echo window focused on speakers, cues, and slides. We just had discussion about this. The icons have changed, in fact. This is hand icon, mic on. Please don't use the mic icon until acknowledged by the chairs. You just saw a demonstration of this, and what you're looking at will be uploaded at some point as a yet new and improved version of the chair slides. In general, we need reviewers for documents. If you are interested in your documents reviewed, please review other documents both here and help out other working groups by reviewing their documents. Perhaps people will help us out. And listed on this slide is some IDs you can review. SCTP core standard update. The main 4960 BIS draft is getting mature. UDP options and all the various other docs related to EC in this working group. Okay, cause of the status. First of all, the diff serve and RTC WebQoS draft has finally been published as an RFC. The infamous WebRTC cluster 238 was popped out, and we did in fact manage to get the process of the RFC editor right. It includes the updates we need to make for the lower effort PHB, which itself is documented in RFC 8622. We have one ID at the IESG finally, the Transport Hair Confidentiality Impacts. I expect the IESG will be taking this up not too long after this meeting week. We have one IDs with the AD review in progress. This is the SCTP NAT draft. I've seen a major review from the AD in the past 24 hours. It's funny how meeting week is a forcing function for stuff to happen. Anyhow, expect to see more on that draft in the near future. We have two IDs, working group chairs and authors after working group last call, and again the meeting week has functioned as a forcing function, and that new draft's been posted with what might be close to the final text. Yours truly, who is the shepherd for these two drafts, is getting tired of reading off the status. These drafts will be submitted to the IETF for publication by the next IETF. I think we're fairly close, and I'm going to put in the effort to get it done. Okay, here are the additional working group drafts. There are 6 of them. SCTP, 3 L4S drafts, the non-Q building PHB, and UDP options. And as we get things out of the working group, we'll have some bandwidth with which to take on new work. One of the pieces of new work that does look like we really do need to take on in fairly short order is there's a going to be request this meeting to adopt the L4S operational guidance draft. Okay, whole bunch of related drafts. Let me see if I can go through them quickly. PathMTU discovery continues to be an active area. Gory has a draft on how to do this for UDP with UDP options. There is a draft over in 6man on how to do this IPv6, and a draft in the TRAM working group on how to do this for the stun NAT traversal mechanism. For SCTP, Michael Tuxson has a couple of drafts, one on UDP encapsulation, one on multipath, and DiffServ, DSCP selection. Ana Costura has a draft on this. This showed up very close to the meeting, so we did not put it on the agenda. However, it is a very promising draft. Please read this, as it's likely to be a candidate for working group adoption. This is trying to roll up all the things we've learned the hard way about how to assign and how not to assign DSCPs to new per hop behaviors. More related drafts. Inbound distro guidelines, multipath DCCP. I have a status slide on that, which we'll put up in a little bit. Network layer multipath, application aware networking. Oh gee, I misspelled that word, didn't I? Hang on. One of the nice things about being this mode, I can fix my mistakes in real time. Primary draft to read is the gap analysis draft. Not for discussion here. This is a topic of interest to a lot of areas in IETF. The primary discussion forums for this will be the routing area working group meeting on Thursday and the int area working group meeting on Friday. And we have a new draft on transport for satellite, yet another chapter in this ongoing adventure. Okay. We're about to go bash the agenda, but the basic outline is document accomplishments and status today, which we're in the middle of now. Milestones review coming up shortly. Drafts. Wednesday agenda, more drafts, and in particular, the game plan is that Wednesday is pretty much devoted to the L4S work, on which we are endeavoring to make progress, and so that's what the entire Wednesday agenda is going to be devoted to. Also notice that this agenda is completely full. It looks like we may want to ask for 4 hours next time. 3 appears to be no longer enough. Okay, milestones review, and I'm going to try and take notes as we go along. We had this optimistic notion that we'd be able to publish the L4S architecture draft before the 2 main protocol drafts. Not happening. So L4S architecture needs to move to October 2021. The next 2 milestones are for our 2 ECN and CAP drafts that have been hanging around for a while. I just promised that those will be done by the next IETF, so those 2 milestones change to June of 2021. SCTP. Michael, if you're on, please turn your mic on and tell us what a reasonable time frame for SCTP might be. Go ahead.
So, I mean, we can just, from my perspective, it's ready for working group last call.
All right.
David, I've done a review of this, and I concur with Michael that we should ask the working group if we can find reviewers for a last call at this meeting.
Okay, we'll go look for last call reviewers during this meeting, and I will put September 2021 on that as a new date. That way, we've got if things happen and summer occurs, we've still got a plausible milestone. It would be lovely if we could get this done between now and next IETF. But I've been through we're going to get everything done by the next meeting, and then discovering that 1/3 to 2/3 of the things in the next meeting bucket don't make it. All right, transfer options for UDP. This one has been running slowly. I don't know, push it. Gory, what do you think a time frame for this one might be?
Well, it depends after this meeting. Joe's going to present very quickly the changes, and there looks like little needing to be done. So we're looking for reviewers here to understand whether we can group last call that. So that could be quite soon as well.
All right, I will make a note to discuss that in Joe's session. NQB is approaching completion. We think we're going to need to get some reviewers' attention to it. I think I'm going to apply the same algorithm to NQB that we just applied to SCTP and put a revised date of September on that. Greg, if you're on the call, feel free to turn on your mic and revise and extend my remarks for me.
Hello. Yeah, I think the draft itself is in good shape, and we'll have a longer discussion later today on that. And only one kind of new aspect that was introduced since the last meeting that needs some discussion. Other than that, the draft is in pretty good shape.
Okay, so I'm going to put a September date on that draft and the SCTP draft. With that gives us a meeting cycle to work through the one new issue. Then we've got the L4S, the three L4S drafts, including the one in the previous slide, are currently set for October. That's not a bad date yet. Let's leave that alone. Okay, quick review of the agenda. We've just done the chair's update. Announcements and heads up, that's going to come after I run through the agenda. Among other things, we've got a couple of liaison statements that I need to briefly call attention to. The chairs have to respond to. We'll go immediately SCTP drafts, then Joe touch for UDP options, the NQB draft we just talked about, and Anna Kostora has once again folks in Gory's group at have gone and measured the internet again, and we have some interesting implications for measurements of use of DSCP2, which is one of the key proposed DSCPs for NQB. Then the rest of today is a couple of individual drafts. QLog has been proposed. I think initially, the Q, I think it may have initially stood for quick. It no doubt stands for something else now. It's looking like a general logging mechanism. We want to get some airtime here to see what people think of it. And then we have some measurements of ECN at an internet exchange provider that we'll talk through. This was written in MapRG. We'll talk through some implications here. This is in some ways a setup for Wednesday, which is L4S day. You'll see, we're going to start with the L4S operational guidance draft, which working group adoption requested. We then have the three main L4S drafts, and Ingemar, if we have time, Ingemar will have the opportunity to talk about some of the work he's doing at L4S and 5G. Gory, go ahead.
I just wanted to note that we have more requests for time than we could accommodate this time. So if you're going to make a request for time at an agenda in a coming meeting, please do it ahead of the time so we can get a feel as to how much time we need and how to allocate it.
Yeah. My initial take is we need to ask for 4 hours next time, and that we could easily have used another hour that we don't have for a number of drafts that would like some airtime, and it would be good to give some of these drafts airtime, but we just don't have the time. Okay. Anybody want to bash or Martin? Go ahead.
Pass. I was just going to remind you to do this.
To remind me to do what? Ask for 4 hours next time?
No, bash the agenda.
Okay, so now we need to bash the agenda. And Marcus, I know you want to bash the agenda.
Hi, Marco speaking, author of the multi-pass DCP draft. Somehow we had an issue in our conversation because I intended to request this time adoption, but unfortunately I haven't got a slot. And my question is, do we have somehow 5 minutes to discuss adoption this time?
Let me go. Let's try to do that fairly quickly. I believe you sent me one slide. Let me see if I can fish it out of the chaoses masquerading as my email inbox. Yeah, there it is. Let's put that one slide up. I think the right thing to do is going to be to handle the adoption call on the list. All right, now I've got the slide up. Now I got to figure out how to do stop screen share, share screen, hang on. Yeah, that one. And if I've done this right, your one slide is showing up. So you want to say a few things about this slide, Marcus?
Yeah, sure, I can do. So maybe some of you have seen that we make some significant progress on the multi-pass TCP, so we updated the draft. What we exactly did, you find in the on the Tsvwg mailing list. So there's the link which guides to this email. We have a new contributor to the draft. It's British Telecom. And I think most important this time, we have published the multi-pass TCP open source, so you can get all the information, how to access the code, how to use it, how to maybe set up own test beds. You find under multipassTCP.org. Then we have also seen that some parties expressed their interest in multi-pass TCP. It was Casa Systems or Telefonica and so on. I cannot remember all of them. Yeah, that's why my plan this time is to request adoption, and happy to discuss this now with you.
Okay, so I think we want to go ahead, Corey.
Okay. Yeah, can I? I'm pretty sure, as we've been through this before, that if the IETF is to do work on DCCP, this is the right working group. So I think you're in the right place. DCCP isn't a protocol we've seen a lot of active development and implementation activities around recently. So we would be very interested in people who would like to implement this and see a need for an interoperable standard. So if you're in the area of implementing this, if you plan to implement it, if you plan to use a standard if it's produced, then these are the things to speak up with on the list that will help us frame this question about adoption.
Mm-hmm.
So, Gori, sorry for asking again, because my impression was, or that was also what we discussed last IETF, and my feeling was now with publishing the multi-pass TCP open source as part of the Linux network stack, also multiple parties who expressed already their interest on the mailing list, that this is or should be enough to request the adoption. Am I wrong here?
It's enough to start asking the question about adoption, and there'll be more questions to follow. These are encouraging answers. I like the answers I'm hearing. We will have to discuss this on the list. The other thing is, when you say part of the Linux stack, is this core, as in, is this a part of the mainstream release that you're planning, or is it
no, it's a parallel tree. It's a parallel tree.
Right, okay, so it's good for experiment, it's good for finding out about interest, it's good for doing work with, so that's good. This is something we obviously have to talk with you, and we can also talk about this in a separate catch-up meeting with you. But please use the list to discuss this.
Okay. Yeah, thank you.
Jonathan, are you in queue for the same topic?
Just a tiny agenda bashing thing that I'll be talking about Pete Heist's draft instead of Pete.
Fair enough.
Okay. Fair enough. And as I noted in the chat with you previously, just prior to this meeting, when Pete got cut from his questions in MapRG, there simply wasn't time to really ask questions or go into the data. So we'd like to open with questions around the data sets that have been produced and see how that goes. I think it would be useful to be able to talk about that data. It's useful data.
All right, we'll go with that.
Okay, sounds good. All right.
What are we on to other new drafts or liaison statement first, David?
Yeah, let me first turn that off. And my apology is taking me a little. I will get better at clicking through Meet Echo as the meeting goes on. But where I think we are now is we are back to here. Okay, and we need to quickly talk about liaison statements. So there's two of them. I'll quickly talk about WBA statement. WBA has sent us a liaison statement about QoS across Wi-Fi and 5G. The chairs will be working on a response to that statement, and we will deal with the content of that response on the list. Gore, you want to cover the 3GPP liaison?
There is a 3GPP liaison in preparation regarding the need for using DTLS with larger messages, and this relates to the STTP draft that Magnus will present. So I guess we will hear more in Magnus's talk later in this meeting.
Which is in 4.2. And I think that takes care of the announcements and heads up, and apologies that we are in fact short on time and needed to constrain the MPDCCP draft to that heads up, and we're not able to accommodate these other requests. I have taken a note that we've got to ask for 4 hours next time. Okay, let me stop screen sharing, and Michael, you want to start talking about 4960 BIS, please?
I think you offered Tom one slide.
I'm sorry?
So who's running the slides?
David,
Happy to have you run your slides. I think this seems to work.
So I should run the slides. So are you running the
Yes,
slides or
please.
should I run?
Please, Michael, please run your own slides.
Okay.
David, we need to come back to Tom's one slide after.
I wasn't aware of that one slide. Let's get, okay, new screen share is getting started.
Yeah.
Yeah, give me it looks like I can't select the window. This is the interesting thing. I have to do the whole monitor. Okay.
I can share just the window if you'd like me to do that.
That would be perfect.
Okay, done. Hang on. Now you get to see how fast I can click through this. Yeah, I hear lots of complaints from people about how some of these tools work better on Windows than Linux. Okay, did that come through, Michael?
Perfect. Next slide.
Cool. We know what it's about?
So this time, 2 updates of the documents have happened between the last IETF and this one. The 08 version is about the transition from XML v2 to v3. So if you compare both, you have lots of white space changes. And the Appendix A, which was about ECN, has been removed, as we discussed the last IETF. And Gori sent comments, and they have also been addressed in the version 08. Version 09 incorporated basically 3 reviews. And if you go to the next slide.
One quick question as you go through accepted. Well, PathMTU is a really common concept. I had 3 related drafts on there. Do we have someone in the working group who's trying to write a herd on all the various drafts that are working on PathMTU?
I would say how I use this and what the comments are. So the document So I got lots of editorial comments, but this one was, I would say, not only editorial. So in a lot of places in the document, something about the size of the packet or something like this was mentioned, and it was vague, intentionally vague, and this doesn't seem to be appropriate anymore. So there are two contexts. One is a size argument related to the size of the packet, like does it fit, does it need to be fragmented, and so on. And so I changed the usage there to PMTU, which means the maximum size of an SCTP packet on a particular path, and the size of the SCTP packet is the size of the IP payload. So that's PMTU. That's consistently used there as PMTU. And the size was also used in the context of receive window, congestion window, where you increase and reduce numbers. And there we use now PMDCS, which is the path maximum data chunk size. And if you are within the context of this document, it's just the PMTU minus the size of the common header, minus if you're not a multiple of 4. If you have auth, SCP authentication, then you have to also subtract the size of the authentication header. But so this is now handled more precisely. If you want to change the names, I don't care to change the names. Some of the suggestions which haven't been accepted was split fast retransmission. There was a suggestion to include this, but this is used for multipath transport, and multipath SCTP is not something the working group wants to work on. So I didn't accept that. The other one was that the association fails eventually if the peer does stop reading user data, and this is not how transports work. So if the connection stays alive in the sense of you can reach your peer, the peer just is not reading anymore. That's an application layer problem, but not a transport layer problem. The next one was that out of the blue packets should only be, so a packet should only be out of the blue if it's for a particular endpoint. So if a host running a kernel stack gets a packet and there is no open port for it, it shouldn't be considered out of the blue. So this is, in my sense, not what out of the blue means. There was a suggestion to change that a receiver may send an abort in response to an out of the blue packet. Currently the text says should, and this is a protection mechanism for nodes not running SCTP, and it should stay there. And the last one was to provide a parameter set which is more appropriate for signaling networks, but we have been through this discussion of, I think in 1999 or 2000, where the IETF does things for the internet and not for signaling networks. So the parameter sets are for signaling for the internet, not for signaling networks. I listed the people who provided feedback. Thank you very much. I pinged 3 additional people I haven't got feedback from, but I pinged them again. So from my perspective, to go to the next slide, the document.
Too many screen, too many windows.
Yeah.
Next slide. There we go.
Yeah. So I got one comment from Magnus that he wants a definition of control chunk, which is now in for the next version. But except for addressing new comments, there is nothing on the to-do list. So please read it or start the working last time.
Okay, I see Gory wants to say something. So Gory, go ahead, and then we need to figure out what to do here.
Okay. Michael, are you familiar with the implementations? Are they following this update? Is this new stuff to them, or is this stuff that's already done and needs to be documented?
I'm not familiar with the Solaris implementation, but Linux and FreeBSD should be more or less compliant.
Excellent. If people want to comment on that on the list, that's fine. Okay. Well,
so let's try something innovative here. We need some working group last call reviewers. if you're willing to review and comment on this working group last call, assume working group last call happens either later this month or in April, please click on the raise your hand join queue icon.
And to clarify, David, if you've already reviewed and would be happy to confirm your reviews, please also click.
Let's see, Magnus and Gory. Okay, and we may try to round up some other reviewers, some of the folks who provided comments who Michael has reached out for comments on. The important thing is we do need to have a number of people read the draft at Working Group Last Call, and a fresh pair of eyes would almost certainly help, as Michael's been working on this for quite some time. I suspect he knows a lot of the text by heart.
Yeah, I guess Timo will reread it. So, but he's not in this meeting.
I can place an extra caveat. If we don't get people to review it, then of course the working group last call won't complete. There's my little threat, but I don't see the reason in avoiding having a working group last call after people have already given review comments.
Yeah, and I think the thing to do will be we, and I think that means Gory, principally, will work with Michael to make sure we round up some committed last call reviewers, so that we get sufficient reviews.
When will you have your revision ready, Michael, for progressing this?
Well, 09 is submitted, so that's ready. And for this control chunk stuff, it's a one sentence. I mean, I can submit it if you want, and then so it's ready.
Yeah, just go ahead and make all the changes, Michael, and we'll try and then progress it.
Okay, so dash 10 is coming soon, and that's the version you want that's ready for working group last call.
So version 10 has one sentence more than version 9. I can submit it today.
Okay,
excellent.
And that is the version. Let me check. That is that the version that ought to be sent to working group last call, in your opinion?
Yes.
Okay, cool. Got that noted. All right.
Well, can I ask for another comment from Michael while he's still here? Michael, could you comment on SCTP NAT? It's received some AD review, and I believe there's conversation about progressing it. Do you want to give in one sentence a current status, or Magnus? Either way.
Yeah, maybe I can start. So provide the context there, because actually working group hasn't seen this. I did a review just finished Friday. I'm sorry for the very long delay here. And my plan here is now, after getting some response, I will update my AD review based on some feedback from Michael and publish and submit that publicly so everyone can see it. I talked to Martin about doing that too. So that's my plan going forward, so everyone can see my feedback here. And then we can have a public discussion, I think, on the mailing list about dealing with some of these issues, etc. But and target. But yeah.
Sounds.
Yeah, maybe one thing I would say is that the NAT document is very old. It started, I think, 15 years ago, with the main use case clients behind a consumer NAT and talking to public web servers, public servers. And Magnus brought up a use case which is with the virtualization stuff, where you have multi-homing is more important. And so we didn't focus on that use case, basically. So that's something we might need to look at or not.
Okay, Martin, and then we have to go back to Magnus because you've got the slides the next session. Martin, go ahead.
Yeah, I just wanted to briefly say that obviously the clock is going to run out on Magnus's AD time, and so unfortunately, well, I'm going to have to read this thing, and unfortunately, you're essentially going to get a double AD review. And I apologize to the authors for that, but that's how it's going to end up working out. It's on my list to read relatively soon, and I hope to get those comments out shortly after this meeting.
Happy to get another review.
Okay, as Shepherd, I think we're happy with reviews. The document has been improved vastly over the time it's existed. And please pay attention on the list to what's going on so you can contribute also.
Okay. All right. And with that, Magnus, you're up. You want to? Can you share your own slides?
I can try. Let's see. I need to click that then, I guess. Yes. Let me.
Bingo.
I will.
I see
And I will
screen.
try. Yeah, I will try to get it to full screen. So yes, this is TTLS over SCTP, an proposed update to RFC 6083. The draft is title is there. It's been worked on by me and my co-authors, Claudio Poriferi from Ericsson, Jan Mattsson, and Michael Taxon from Minster University, Applied Science. So the background for this update or proposal update is that 3GPP in 5G networks uses DTLS over STP, in other words, RFC 6083, for securing several radio network application protocols. And it's slow to update. Okay. Why isn't it updating? Has people seen the update? Seen it in flipping? Let me try.
Magnus, your slides are not in presentation mode, at least what I see.
No, and I went into part. Let's see if it works better. It seems to doesn't pick up.
Updated.
Yeah, I will do it from this view. Let me just. I can do it like this.
Yeah.
Yes. So in 3GPP there's at least 4 different radio network interface related protocols that has the theoretical potential to send messages over 16K, which is the limit to RFC 6083 for user message sizes. This hasn't been, to my knowledge, any real message yet, but as discussion and evolution goes forward in 3GPP, this was realized as they started discussing larger sets, etc. in some cases. So they need to deal with this. And 3GPP wrote round 3, not round 2. Sent an LS asking TSPW to address the issues. There's an action in that to respond if we can deal with it, etc. So that's going to need a response in some form to 3GPP. And basically, 3GPP would really prefer this a general solution to address this issue than having to try to address it in their individual protocols for each and every of them. So, and that's why they want us to look into if we can update RFC 63. And it really is, the issue here is that 683 maps the user message to a single DTLS record, which then becomes too small because it's only 16K. We also have the issues of RFC 683 security requirements. I mean, this RFC is, I think, 10 years old, and it shows it's DTLS 1.0, and it's SHA-1 in STP auth. Not that it's super problematic for the moment, but at least it's a little bit low on security properties. So the proposal here really is to replace RFC 683 with updated specification, define a secure fragmentation mechanism, and basically it's a very simple message. So looking on the right side of the screen, we have the plain text user message, then fragment that into units that fits in a DTLS records, as many as you need. Then you run on each fragment, you protect that with it to create the DTLS record, and then you concatenate together as a protected user message. Then you transmit it over SCTP on a particular stream as an individual user message. And we basically rely on the STP authentication to ensure that the fragments arrive at the receiver in the correct order and that no one can interfere with it as these aspects of the data being. So you have the STP authentication as a protection for the order of the fragments, and then each DTLS record is individually encrypted and integrity protected. No, I should go back. Sorry. We also have the security requirements fixing that. We also looked into some signaling of supported message sizes by the endpoint. And this is now also defined as an STP adaptation layer and with a handshake indication. And it allows us to do something which avoid some of the uncertainty. So when you're doing this in the handshake, you already know that you're going to run DTLS on all the messages. So you have no question or not if this should be protected or not. We also do like some housekeeping or saying, oh, IData for this larger message is really useful because otherwise you're going to potentially run into some bottlenecks. And we're also trying to clarify some of the DTLS 1.2 renegotiation. So that's the kind of what you're trying to accomplish here with the updated proposal. Then we have, as I said, this is still relying on STP authentication. You can't use this without it. STP authentication is keyed by the DTLS, and the DTLS fragmentation mechanism and replay protection of DTLS records is provided by the STP stack and authentication. So it's nothing, no data should ever be duplicated up towards about the STP layer. If any attacker tries to duplicate data, it should be caught and handled by the stack. So. However, we do have some open issues and some work in front of us still before this is ready. One of the issues we actually realized is that DTLS 1.3 and rekeying for long-lived flows is problematic. And the basic here is that DTLS 1.3 do not support renegotiation. So there's no post-handshake server authentication. It re-authenticates client. It doesn't rerun Diffie-Hellman or exporter secret updates. So it can rekey in a certain way, but it has some mechanisms that's not ideal for having long-lived sessions. And when I talk about long-lived sessions here, we're talking days, weeks, months for some of these usages, for example, in mobile networks. So it's not really practical to tear down, and it's also not particularly practical to tear down and re-establish, because that means that you have to bring maybe whole cell sites down, etc., for doing that. So it's really not something we want to do. So we have started some discussion in the TLS working group about these things for the TLS 1.3. So we'll have to see where this is taking us, but at least it's an issue which is ongoing, and therefore DTLS 1.2 support will be crucial initially for ensuring that property for long-lived flows. And we also, this adaptation layer and being certain that everything is protected by DTLS is good, but I want to point out that Start TLS will not work under these restrictions, and therefore it's a question more than anything to see if anyone has issues with us taking this direction. And we also want to clarify a bit about the partial delivery of protect user message between the STP stack and the upper layer of DTLS here, and what happens when you actually don't get all the data and what you do. We also seen these socket API changes maybe have some need for that, because if you're requesting, for example, that you should use SHA-256, the current socket API for STP auth, it's not clear on which handling this, like on the algorithm side, etc., and putting requirements on those things. So we're going to see something there we need to deal with. So. But the main thing here is that we actually want to request a working group adoption of this. As we see it, it's 6083 do need an update to resolve this length restriction. It's also a good time to actually update the security algorithm requirements. And we do have a time frame from 3GPP in some sense, because they want to fix this, I think, in the current release, which is by March 2022 is the stage 3. So we need to have something ready that by then, basically. And we think we can do that. We have a year. And so discussion, we're gonna start sending out some of the open issues on the mailing list. We have some more editorials, etc., to work on, and we do using GitHub for this. So we have source. You can submit pull requests or file issues on this link. So, Gori.
I can see the suggested need for this. I wondered whether anybody else in the working group had any comments on the work you've presented or had interest in this topic. Is there anybody interested in the topic that Magnus has presented or thinks they would have expertise to work on this?
Hanu?
Yeah, go ahead, Hanu.
I'm interested in the this needed this extension. I'm interested in the work.
Okay. Well,
and this is David. I think I'm interested enough to find the time to read the draft. Magnus, let me quick understand something. This draft is the anticipated response to the 3GPP liaison statement that is supposedly inbound. Is that correct?
It's not supposedly. It has arrived. So it's we find
Has arrived.
But yes. So it showed up on Friday, or we managed to get it posted on Friday. I was blaming Gonzalo for this. It was tracked there. So, but yes.
I would suggest that we take the time to review that liaison statement and then launch an adoption call on the list with reference to that liaison statement.
Yep.
Yep, I agree with David on this, and I think this work definitely falls within the scope of this working group. So please read the draft, please look at the liaison statement, and please comment on list when we make the adoption call.
Okay, thank you. Any more questions or?
Some of the people in the chat have said that they're interested as well.
Good.
Good.
Okay, and I'll stop sharing it.
Thank you, Magnus.
All right. Next up would be UDP options. Is Joe presenting or is someone presenting for Joe?
Yeah, guess who's going to volunteer? I'm doing it.
Hi, Gori. Yeah, yes, you're the usual suspect on this one.
And I don't have Joe's shirt to go with it, I'm afraid. It's a bit too cold up here, but let's talk about UDP options. Can we get the slides, David?
Where would I find said slides?
In proceedings?
Oh, now I got to go over there.
That's fine.
Justin,
I can talk while you're doing it. So, Joe's been working and responding to comments on UDP options for a while. This current draft 09 is very much an update that includes responses to nearly all the issues which have been raised previously on the list. So Joe has a set of slides that reviews each of these in turn, and we'll briefly tour over those with the last couple of issues at the end where he wants help from the working group. So when we get Joe's slides.
Just a minute. The slides are on my screen. Now I got to get them on yours. Hang on a minute here.
That looks good.
I believe that's the one. Okay, that looks good. Bingo.
So this is Joe's set of updates. He's made changes since 09. He added the unsafe option, which is specifically for use with fragmentation. It tries to overcome the issues which we talked about in length at 2 in-person IETFs, so a little while ago now. And it's produced a simpler fragmentation method. He's also integrated fragmentation and light so that they're no longer separate things. And he's revised the OCS pseudocode with more input from Rafael Zulo to fix the zeroing issue. He's clarified the ACS is not dropped by default, related the ACS and the CRC32, and also talked about ACS and AE to say that they cover the payload only. So a number of things all being talked about on the list, all in Joe's latest post to the list. So we can go quickly through them. Next, please. Unsafe is basically there to deal with a specific option that follows another option, and we need to judge the safety. So this is the one place where the results of the receiving a UDP option datagram doesn't result in the application receiving the datagram. So it's an important case, and Joe's written text to look at this, and it's in the latest draft. So that's around, and Joe's email documents it. Next one. Most of that is related to fragment, and the idea of fragments are to provide some RDMA-like avoidance of copying user data but providing fragmentation. The main reason for highlighting this here is the expected use case by Joe includes DNS, and DNS needs to send large records, and this would be the mechanism that would be used if UDP options were used with DNS. So it's important that people who have DNS clue look at the fragmentation part. Next slide. ACS and AE have been revised, mainly revising the text, so not a lot of surprises here. Next one. Option processing principles have been clarified. Joe has strong opinions on this, and he's expressed those consistently on the list, and they're reflected in the draft. I think it's clear. There's a new issue, and the new issue is one related to PathMGU discovery again. It's a very small thing, but Joe's looking for clarification. When we talk about the largest segment size for a UDP datagram, do we mean the largest size of fragment, or do we mean the largest size of fragmented data unit? Which one of these two numbers should appear in the MSS options? The maximum fragment size or the maximum fragment set of fragments that can be reassembled? So there are two different parameters, and they can be used in two different parts of the algorithm. Which one of these is most useful? Which one of these should be in the spec? I ask the questions because they are things that Joe's going to have to ask on the list to finish this. This is the main issue that's remaining. Next slide. There's also a few pending changes, but these are not thought by Joe to be significant. He admitted that he misunderstood the way in which ROC 3095 was specified. It's complicated. And the text has been updated with help from Carsten Bormann to get the text right. So the text currently in the draft should be correct with respect to ROC. This isn't really a change in UDP options, it's a change in text. The second one is how do we address the MSS issue? What should be in an MSS option? What number goes there? And if these two things are fixed, then this document is complete in the respect of all the issues that were raised by the working group when we did the review. So is there anything else that needs to be covered by this document before it goes for a working group last call? That's my brief summary of Joe's slides. I'll happily take questions if there are any.
It sounds like we need to resolve the MSS issue, and working group last call can follow, assuming there's no surprises in the others. And working group last call might be just a real good idea, simply to turn up whether all the details are right.
Yeah, if you picked up on my representation of Joe, if you're from the DNS area or an area that really would like to use a feature for sending fragments across the network or some other part of UDP options, please look at this now, because
Should
there's
we lob
users in the room.
Should we lob an early review request over to int areas? I think that's where DNS lives.
Yeah, we should do that when we do version 10.
Yeah.
Okay.
Hang on, let me make a note to myself. I can't write this morning.
All right.
Okay, now with a little any other comments on this before I go and switch to NQB?
I think we should go for NQB.
All righty, here we go. It takes a few clicks here. I'm getting better at this though. Should be that one. Yeah, it's that one. Greg, go ahead.
Excellent. Thank you. Be able to hear me?
Yes.
Yes. Okay. Good. Getting a pop-up saying it can't detect my audio. All right. So there have been a couple of updates to the NQB draft since the last IETF meeting. Draft 04, which I uploaded at the deadline for the meeting, it covered most of the changes that had been discussed at the last meeting and afterward. And then while I was working on putting my slides together for this talk, I realized there was one of the to-do items I had not actually gotten around to doing. And so I did that in this draft 05, which was published just as the servers opened again for this week. So, and in the process, did a little bit of wordsmithing as well on draft 05. So the draft 4, the main changes are first aligning the terminology with RFC 2474 and kind of cleaning all that up, where it talks about standardizing PHBs and recommending DSCPs and not the other way around or some other permutation of those terms. I think that's good now in the draft. There's also a mention that DiffServ was not intended for end-to-end usage, and that's been reworked with some help from Brian Carpenter on that. And then additional requirements. So this was discussed at the last IETF around the implied behavior in earlier drafts that a network node or network that doesn't support the PHB should be aggregating NQB traffic with default traffic. And so now that's explicitly stated in the draft now. It's a little bit odd to be saying in a standards document what non-compliant nodes should be doing, or adding requirements for nodes that don't support the PHP. But nonetheless, I think it's valuable to do so. And it is really the intention of the NQB code point and traffic marking that if it's not being queued separately along the lines of what the draft discusses, then it really should be aggregated with default traffic. And then second piece was preserving the NQB marking. And
that's gonna have to be wordsmith, but I understand why you want it. It's grim reality has a second opinion.
Right, it's just a should.
Yeah, I understand. It might not even make it to that level. I'll work that off list with you.
Okay, well, appreciate that. And then there's around that discussion of aggregating with default and the requirement or the should around that, there is a discussion around where that is probably fine. In particular, it talks about shallow buffered switches and core network routers and switches that are not typically points of congestion and points of queuing delay in networks. Next bullet, removing a mention of aggregating network control traffic with NQB. So this is in the discussion of what traffic could be aggregated potentially in a node that supports the NQB PHB. What other traffic might you want to potentially aggregate with NQB marks traffic? Network control was initially listed there, and I was asked to either put a lot of guardrails around that in the text or not mention that. And so I took the easy path of not mentioning it. The last bullet in that first, last sub-bullet, I guess, in the first section there, underlined, this is the new piece that I'd like to spend some time discussing today. And this came out of reviews from a number of folks in the working group and suggestions on what would make lives easier for people to comply with some of these requirements. And it amounts to asking for 2 code points to be assigned by IANA, and we'll go into the detail on that on the next slide. And then for the draft 5, the new updates, the one piece I had missed in the draft 4 was adding something more clear in the Wi-Fi section, that rather than just talking about interaction or interoperability with existing Wi-Fi networks, really talk about the goal is that Wi-Fi networks in the future actually support the PHB, and so that should be the recommendation, and then dealing with the interoperability with existing networks as a secondary aspect. So that's now in the draft 5, along with a bit of wordsmithing of the new text that went into draft 4.
Let me quick check where you think the status is. It looks like most of the issues have been closed. There's one major issue on the next slide about 2 DSCPs, and once that's resolved, plus a little more text cleanup, this is ready for working group last call. Correct?
That is correct.
Cool.
I believe so.
All right, so here we go. Biggie.
All right, so 2 DSCPs. So we're trying to work within the realities of the world as it is, maybe not as we wish it were to be. And so there are some constraints on the selection of the code point to be used for NQB in order to make it useful in the near term as well as the long term. And the 2 main constraints conflict with one another. The first one is that there are hundreds of millions of Wi-Fi networks deployed around the world that map DSCP into access categories, the WMM access categories, which provide separate queues as well as priority, but provide separate queues. And that mapping is by and large using what's called the default mapping. And there is an interest in ensuring that the NQB code point can be handled in these existing Wi-Fi networks, and that NQB traffic can get a separate queue from the best effort default traffic. And so in order to do that, we have, since the beginning, proposed that the code point allocated for NQB be value 42, which has the bit pattern 10 and then 1010, which would by default map into the video access category. Actually, any code point with the value, the binary value 10XXXX would map into the video access category on Wi-Fi. So that's one constraint. A related constraint that works well with this assignment of value 42 is that there's a lot of existing access network gear that can configure classifiers to put traffic into different queues, and has bit masking capability in doing that DSCP matching. And so selecting a code point that is maskable and matches a set of other code points that are already assigned by IANA that carry traffic or indicate traffic that is compatible with NQB is a distinct advantage. There are a number of applications today that already mark their traffic with some existing code points, in particular CS7, CS5, and EF, that is traffic that is compatible with NQB and selects either the voice or video access category in Wi-Fi. And the belief is that continuing to support those, or supporting those applications in networks that want to implement the NQB code point would be facilitated by selecting a code point for NQB that can be easily grouped with some subset of those 3 code points.
Minor note here, use CS5 and EF as motivating examples. Applications should not be marking CS7 because most diff-serve boundaries have to bleach CS7 in order to protect the routing protocols.
Mm-hmm. Yeah, and the context for that list really is in end user networks, home networks, and there CS7 actually is used because the default Wi-Fi mapping maps CS7 to the voice access category. Things like EF and voice admit go to the video access category by default. So dealing with the reality of usage in home networks. But point taken. The next rationale there that conflicts with the first one is that across interconnections, it was pointed out that particularly for networks that run MPLS cores, that traffic has to be aggregated, or DSCPs have to be aggregated in order to fit into the available MPLS traffic categories, and that NQB traffic could very easily be treated the same as default, which would be the intention in a core network in a lot of cases, if the code point were something that matched the pattern 000XXX in binary. So, if such a code point were selected, then those MPLS core networks and transit networks could very easily carry the NQB code point through unbleached. And so that both of those are desirable properties that would enable end-to-end usage of NQB in the near term. So that leaves us with these 2 conflicting constraints around the assignment. Again, one being that the code point is binary 10XXXX, the other one that it's a binary 000XXX. In some off-list discussion, we came to the agreement that it would be a potentially useful set or a pair to choose would be 42 and 2. 42 matching what we've been proposing all along for the Wi-Fi coexistence and access network coexistence aspects. And then the value 2 is simply bleaching the top 3 bits of the code point. That is actually already a pathology that's in place in some parts of the internet, and so naturally DSCP42 marked traffic would become DSCP2 in some cases, and in other cases it's an easy fix or easy change to make in the DSCP. And so the way that's kind of structured in the draft is that end hosts, applications, essentially mark traffic as 42 as they send. The host is the entity that understands its sending behavior and understands whether it's complying with the intention of the NQB code point and the PHP, and so it marks as 42, and then that then traverses home networks and Wi-Fi links and gets the appropriate treatment there. Gets this benefit on access networks of having the value 42, And then somewhere prior to interconnection, the ISP is responsible for remapping 42 into the value 2 and using 2 across the interconnection. And then at the far side, before traffic is delivered into an end user network, there is another remapping back to 42. And the diagram shows a client and server case. It could also be client to client, peer-to-peer kind of communication as well. But that is the gist of it. And that's, I think, the main discussion point today is concerns or thoughts about the concept of having 2 DSCPs to deal with this these 2 constraints, and then the specific values of the code points. I think 42 and 2 is maybe a secondary topic that we should touch on as well. So, to see if, I guess, if anyone has feedback on this 2 DSCP concept, any concerns with that?
Okay. Do you want to get the discussion now, or get through the rest of your slides? We're a little tight on time as usual.
Okay. Well, I can. The rest of the slides are kind of wrap up, so I can go ahead and do that, and we can have open discussion. That's okay. Good. Okay. Next slide is just.
And the other thing is we need to figure out where to put in the Anna's presentation on DSCP2 measurements.
Yeah.
Okay. So
yes,
remaining slides.
Okay. So this is just to say everything that we identified the last IETF to do is either done or we decided not to do it.
Checklist checked. Next.
And then discussion. So okay with 2 DSCPs, and then which ones? And so see Anna's talk, which has some interesting insight into that topic. And then where do we go from here on the draft?
All right, so what we're going to do is get Anna up to talk about DSCP2, and then come back to this for some more general discussion, and try to watch the clock while we're doing that. Okay, hang on. Where am I? All these windows. Okay. Hang on a minute here. There it is. Anna, go ahead.
Hello, can you hear me?
Yes.
Great. Yeah, so hi, I'm Anna. I work with Gori Fairhurst at the University of Aberdeen. I will talk to you today about some measurement data, new measurement data that we have around the code points 42 and 2 that are proposed in the MQB draft that Greg just presented. So if we could go on to the next slide, please. The data is new as it addresses some gaps. There already is some literature about the traversability of code points, including 42 and 2, but only in the core of the internet. And all of that is based on active measurements. So you generate traffic with some DSCP, and then you set it out in the internet, and you look at what comes out of the other side and what changes you see at every hop in the path. But today, what we are going to be looking at is passive data in the core of the internet. I mean, actual traffic in the wild. And this is a data set that is provided by CADA. We're also going to be briefly looking at a set of edge measurements that are done from RIPE Atlas probes. In the past, we've not had that much information on edge networks. And finally, I've looked at a few sets of code points, primarily the DSCPs 42 and 2, but then a couple of other pairs that would fulfill the criteria that Greg just talked about, that is also specified in the MQB draft. So if you could go on to the next slide, I will try to keep this as short as I can. So the passive data, this is provided by CADA. It comes from a monitor that sits somewhere in a data center. It collects all the traffic on a backbone link, where a tier 1 ISP peers. The traffic is anonymized, all of the payload is removed, and what we are left with is IP headers and transport headers as well, so we can look at the DSCP markings. In total, we analyzed around 18 billion packets. They were all collected in 2 hours in 2 different years at the same location. if we move on to the next slide. And yes, here is a table that analyzes what DSCPs were seen on all of these packets we looked at. And I pay particular attention to those that are proposed in the NQB draft. So as you can see in the table, I've split the traffic per year, per direction. The traffic is bidirectional. And also per protocol, as in IPv4 versus IPv6. I've not split it per transport. So first observation that you can make is that the most traffic just carries DSCP 0. So only zeros are carried in the DSCP field. And this is the case for around 80 to 90% of the traffic, regardless of how you split it. We expect this, and this corresponds to be the best effort. The second thing that you can notice, which is a bit more unexpected, is that in all of the cases, regardless of how you split the traffic, you can see traffic marked with DSCP2, which is proposed in the NQB draft. In fact, this can be as much as 90% of all the traffic carries this particular mark. This is not a trivial amount of traffic. We'll explore why this happens in a later slide. But something else to notice here is that all of the other codes don't appear, code points rather, don't appear nearly as much as code point 2. And this includes code point 42, which is proposed in the NQB draft. That's a good thing. It means nothing uses it. But also in for all of the other sets of code points that we used, we looked at, like 44 and 4 and 46 and 6, they don't appear. They only appear for a fraction of the traffic. So the key takeaway from this slide is that on this particular link, a lot of the traffic ends up carrying the same code point that is proposed for NQB traffic. And because we see it in both directions and from different prefixes, we believe it to be the result of several different networks, so not just one network, but several that we mark in this way. So if we could go on to the next slide, which talks about the test that we did at the edge. So we did this test on the RIPE Atlas platform, which has geographically distributed probes. And in fact, in the picture that you can see on your screen right now, these are all the probes that participated in the measurement. And from all of these, we sent TCP traffic marked with DSCP42 towards our own server at the University of Aberdeen. And the goal here was to understand what remarking happens along a path. Note that this is a traceroute measurement, so we can actually see what happens at each hop. And what we find out is that not much remarking happens at the first hop, so in the edge network where the probe is, with only about 5% of all of the DSCPs are zeroed there. But by the time the packets make it to our server, to the end of the path, DSCP42 survives only on about 20% of traffic, so on around 20% of the paths rather. We also see that about 7% of packets have the first 3 bits of the field zeroed out. So this is basically toss bleaching. So they arrive at the destination as DSCP2, which is the other proposed code point for NQB. And interestingly, you see about 3% of them that have the last 3 bits as opposed to the first 3 bits zeroed out, which results in code point 40 or CS5. Greg mentioned that CS5 is NQB compatible traffic, but also in this case, it might result from a Wi-Fi network pathology. However, on the majority of paths, this is not the case. On about 60% of the paths, packets have the entire field zeroed out. So by the time they reach the destination, they carry DSCP0, and this corresponds to best effort. So if we move on to the next slide. What do we learn from all of this data? Well, I just mentioned that where edge networks are concerned, you see a lot of bleaching and resulting in code point 0. But the KDA data results were surprising because now we know of at least one backbone link where using code point 2 is used and appears on a lot of the traffic. And this is most likely due to the toss precedence bleaching on many packets that maybe have arrived from various edge networks carrying DSCPs such as AF11 or AF21 or 31 or 41 that toss bleach to the value 2. So what I'm trying to say is that you have these popular code points like AF11 and 21 that have established semantics, which end up at the other edge as 2. Because of how popular they are, and because there's a lot of because the practice of toss bleaching is still quite widespread. I'm guessing this might mean that you could have potentially a lot of queue building traffic that may be remarked as NQB, and that's the only implication here. But we also saw that code point 42 is not used. Which brings me to my last point. And if you go to the next slide. So my last point is that there are a lot of interactions and different types of remarking that can happen on many different paths in many different types of network when it comes to diffserv code points. So all of these kind of should be kept in mind when you assign new ones. And me and Gori and another one of our colleagues from the University of Aberdeen wrote an internet draft that attempts to provide some input on what remarking pathologies exist and what other semantics exist with regards to code points. And we're at the stage where we'd love any input on this. Thank you very much if you've already commented and provided feedback on the draft. We will be uploading a new version soon. But if you haven't and you think you can do so and are interested, please do it. Yes, this concludes my presentation. Thank you for listening.
Okay.
Are there any questions?
Let's leave that. Hang on, where am I? Let's leave that slide up for questions. Greg, go ahead.
Okay, thanks, Anna. This is definitely really good and useful work for helping select code points here for NQB. It looks like a potential candidate pair of code points could be 45 and 5. Going back to your data, it looks like 5 is not used. It was not seen heavily. There were a couple of instances, I guess, the direction B, both 2018 and 2019, where there was a fair amount of code point 5, but in other cases, much less. And the value 45 is available in the assignment pool as well. Those other values 4 and 6, the corresponding value in the upper part of the space, 44 and 46, I think those are already assigned. 46 is EF, 44
right.
is voice admit.
Yes.
So if we want to have a pair for which the low 3 bits are the same, which I think there's value in doing that, 45 and 5 might be one that we look at.
Interjecting as a chair before going, recognizing the next person in line. Voice admit is definitely out of the question. However, EF is intriguing. It might be plausible, since NQB traffic doesn't build queues. If you have high assurance of that, it is not out of the question to carry it as EF in the edge networks. And I don't know how to reach a conclusion on that. I'm just raising that as an interesting one to dig into.
Yes, interesting thought, if you don't mind me responding to that. In existing Wi-Fi networks, EF and 45 and 42 and all those which we've been talking about in that upper range would go into the same access category. And so from that perspective, it would be equivalent. And then if in a further network hop, EF gets aggregated with NQB traffic, either because they're in different code points and they get classified together, or because they share the same code point, that would be fine too. The concern I think I would have is that recommendations around future Wi-Fi support for NQB versus EF. And EF is generally considered traffic that should be prioritized in networks, whereas NQB is explicitly not supposed to be prioritized. And so the recommendation for future Wi-Fi nodes is to provide a separate queue in the best effort access category for NQB. And is that what we would want to recommend for EF traffic as well?
Okay, just want to raise possibility. VD, go ahead.
Hello, can you hear me?
Yes, yes.
Okay, cool. A question for Greg. So for in the NQB draft, I haven't read the draft. I just saw the slides right now. Is there a recommendation for the edge to bleach any of these 42, 44, or 46 to 2 instead of 0, so that it can be utilized for the NQB traffic on the downstream? Is that the recommendation? Because most of the traffic gets bleached to 0.
Yeah, the intention is. Whoa, you gotta go. The intention is that someone could mute their line.
Mute your line real quick. Responded.
Test 1, 2.
I think
All right. I'll try to.
There we go.
Okay, good. Thank you. Yes, the intention is that we enable the pass-through of this code point end-to-end, and we do whatever we can to ensure that that's possible. Yes, today, the vast majority, if not all, ISPs, particularly for residential customers, bleach the code point to 0 or to some other fixed value, most often to 0. And so the recommendation in the draft is that it be carried all the way through, and as the diagram shows, is 42 in the home network segment for traffic both upstream and downstream to the user. There is one kind of caveat there that since the Wi-Fi links don't support the full PHB requirements, that there could be some non-ideal behaviors that might happen if traffic is not being policed and monitored, and random traffic comes into the ISP network marked with this low value, say 2 or 5, if that's the value that's chosen. And so it recommends that unless the operator has implemented some safeguards to prevent that from happening, that they leave the code point at the low value so that the traffic stays in the best effort access category on Wi-Fi. But to the extent that the ISP is supporting the PHB and supporting those safeguards, then yeah, the intention is that it is 42 both for upstream traffic and downstream traffic in the customer's home network.
Right. Now, there is a risk there on this data, which is that there is existing use of code point 2 traffic on the observed on the backbone, and that will get upmarked to 42, even though it didn't start out as 42.
Yeah,
and
exactly.
Gory?
Thinking here that there might be 2 outcomes. The first one might be that after thinking through Anna's presentation and the discussion on this topic, that Greg might finalize on 42 and 2, and that will have to be proposed to the working group. So that's one option. The other option might be that after thinking through this, that Greg wants to try and propose a different pair of DSCPs. And then I'm wondering perhaps if we could have a little interim or something before the next IETF to discuss the different option if one emerges, so that we weren't kind of clocked by IETF meetings on assigning a diff-serve code point.
Yeah, if it gets confusing enough, an interim would make a whole lot of sense. But I think it's definitely possibilities. Anna, you want to take a last word on this, and then we need to move on?
Say that again, please.
Did your mic is still on. Did you want to say anything more?
No, I just had a thought. Because I think whichever route you go, whichever pair of code points you have, do you not need to have some sort of protection just in case that queue building traffic actually ends up in the NQB queue, regardless of what code points are used? So if you have such a box and this box is in the ISP network, perhaps you don't actually need to choose a different pair of code points from 42 and 2. If I understand this correctly.
Okay.
Rudiger might want to make a quick comment on this.
Yes, let's let Rudiger go ahead.
Go ahead.
We'll have a hard time to distinguish it from...
It's coming through now.
Hello?
Yes, you're there.
Well, I'll have a hard time to distinguish it from real NQB traffic at the BNG. So I'd prefer a different DSCP than 2. Thanks.
Okay, so this is a great conversation to have on the list, but I would encourage people to get in there and try and make some decisions so we can move forward.
Okay. All right. And we are 5 minutes behind schedule, unfortunately. Corey, did you want to try to stuff the satellite slides in here very quickly?
Yeah, as we start the individual drafts, let's do a heads-up display of the satellite one and then move through Robin and then finally back to the final slides. Okay, so Tom, please press your mic and talk for 2 minutes.
Yes. Am I not getting audio?
Now you're getting audio. Go for it.
Okay, next slide, please. So Nicholas, Gori, Emil, and John had a draft that was targeting QUIC, where they looked at satellite considerations for the QUIC protocol. And part of that was giving something that was testable by implementation so that satellite wasn't left out of the story. Gori asked me to look at this draft to try and align the text with RFC 2488. And instead, we as a group of authors decided that the document would be better suited just approaching transport protocols generally and what they need to get from satellite and what satellite deployment does. There are 2 documents in the RFC series that really cover satellite use cases, 2488 and 2760. They both came from the TCP SAT working group, which concluded in 2000. And since 2000, geo satellite services become massively faster. There's just a lot more capacity available. And the considerations in these documents were sort of superseded by split TCP implementing the things they discussed. And so the split TCPs are implemented with PEPs. And this works great for TCP. Most TCP connections don't actually realize they're going over satellite because they have the protocol split down. And satellite actually works quite well, apart from for latency critical tasks. The problem we have is that PEPs are a deployment barrier for new features for TCP, and they are impractical to deploy for QUIC or with VPNs. And we're starting now to see new satellite systems that are actually getting prominence. So we're seeing a lot of LEO stuff come up, and we're seeing MEO, and there's a big case with hybrid operations with 5G. And so we want to create an update to 2488 and the advice in 2760, and document the relevant transport characteristics of these satellite networks so that we can give advice for implementers, and so we can design and test and verify that code will work well in these different cases. And what we want from the working group is input on what we need to talk about. And so we have experience with geo providers because the authors group typically work in geo systems. But what we really want is input in LEO and MEO, and then input from satellite network operators, application platform operators, and protocol implementers, so that we're giving the best advice so that the satellite use cases are understood. So I just like to ask everyone in the working group to read the document, and provide feedback. We'll take feedback on the mailing list individually, and we also have a GitHub, and I'll post the link to the GitHub in the chat, and that is all I want.
So please read and comment the draft to the list and or to the authors. Okay, next up is, let me go find it, is QLog. And I would ask both of the next main two presenters to try to do it in about 10 minutes each. Sorry, we're squeezed on time. Robin, go for it.
Yeah, if I can have slides.
Hang on. Just a minute. I need to go. Yes, you do need to let me go find it. Bingo, that should be it. There we go.
Excellent. So thanks for giving me a little bit of time to talk about QLog again, which has been discussed in TSV area before and also throughout the week. So next slide, please. QLog started as the quick logging project intended to make it easier to analyze and debug Quick and HTTP3. Next slide. This is because what you would normally do for something like TCPs, you would take a packet capture somewhere and use something like Wireshark to analyze that. You can still do that with Quick, but it's a bit more difficult. Next slide. Because Quick, of course, almost entirely encrypts also its transport level metadata. So to do that, you would have to store the entire packet capture, which gets quite large, and you would also need to store the decryption secrets, which is, of course, terrible for privacy. There's a second important aspect to this, next slide indeed, is that not everything about a protocol is, of course, sent on the wire. Especially things like congestion control parameters are typically not analyzable in that way. So for Quick, we proposed, next slide, a new approach. Instead of doing a network capture, we would capture at the endpoints directly from the implementations. And QLog there is the idea that we can have a single format, a single schema, that is used across the different implementations. So everyone logs in the exact same way. This enables us to create reusable tooling in a much more straightforward fashion. So next slide. So QLog is far from rocket science. We currently just serialize this to JSON, getting, for example, a definition of what a received packet should look like, or indeed a congestion control metrics update on the right side. Next. So using QLog as an input format, we also created quite a bit of tooling for that. For example, this type of sequence diagram, or next, and a TCP trace-alike tool to help debug congestion and flow control issues in the protocols. Next slide. This approach has worked quite well within Quick, with the majority of the implementations actually outputting this single format, and for example, Facebook actually using it in production at scale as well to monitor their actual Quick deployments. Next slide. Up until now, QLog has been 2 individual drafts, and so because of this, I would say, proof that it can work in practice, we will probably adopt it in the Quick working group within the next couple of months as part of their re-charter. So a main goal of that is, of course, fleshing this out for Quick and HTTP3. But the main reason that I'm here today and other working groups this week is because we also envision QLog to be useful for many other protocols as well. This basic concept of just using a structured standard format at the endpoints can be useful in many different situations. And we actually have pilot projects running for the ones that I've listed there below. For example, TCP is an obvious target there, where we are extracting some events using, for example, eBPF from the kernel. There are also many people interested in doing this from multipath TCP and Quick, of course, because these can get quite difficult to debug and fine-tune in practice. Next slide. This goal of making QLog usable for more protocols is actually already visible in the current drafts. We have the event definitions for Quick and H3 are separate from what we're calling the main schema, which kind of has the protocol agnostic stuff of the format. And the hope is that this can grow to a framework or a set of guidelines that people can use to define new types of schemas for different protocols. Next slide. If you want to do this, we're of course going to have quite a few challenges ahead of us, which is one of the reasons, again, I'm here today in the hopes that some people might have thoughts or feedback on these. I'm going to highlight just 3 of them just to give you an idea of what we might be talking about. Next slide. So one of the things is that a simple thing to do would be to map the wire image that you would get one-on-one to the format. For example, here you have a selective acknowledgement missing the packet number 16. But this doesn't necessarily reflect what the implementation is actually doing. It might perfectly be that packet number 16 isn't immediately declared as lost. And so we need a second type of event, which you can see on the right side, to actually reflect that separately. Now, if we start defining both of these types of events, you get a huge amount of events, first of all, and it also becomes more difficult to build tooling for this, because which events should you be looking for and which takes precedence over the other, and so on. And this is just within Quick. Let's see if we extend this to TCP with the next slide, which of course also has selective acknowledgements, but in a different way, because here they're in the packet header in the options field, and so it's the exact same information, but reflected in a different serialization. And so we really want to find a way to hopefully make this easier, or need to see if we really do need to reflect the wire image completely. The second main challenge, next slide, is on the serialization format here. We're currently using JSON mainly because it's flexible, but it's also not the most performant option, even though it is kind of usable, for example, used by Facebook. But so also in the drafts, we kind of acknowledge that we might want to use different things in JSON. So we have our own data type definition language there to describe the events, which is what you can see on the right side. But we would like to really move to something more officially supported by the IETF, with the goal of automatically generating serializers or deserializers for different programming languages based on this, to make deploying this easier. We would also like to get some insight into, if people would use this, what type of processing or collection pipelines they would typically want to use, which will help guide the correct use of the format. The final main challenge, next slide, is of course the privacy aspects. As I said, in theory, it's perfectly possible that you only log the perfectly sanitized data from the endpoints directly. But in practice, you will have use cases where you do need the IP addresses, you do need the URLs and that kind of stuff. So what we envision now is to have like a set of sanitization levels defined with concrete guidelines on how to hash or obfuscate certain fields that people can then map to individual things. Our hope is that if this works quite well and we can scrub this from most privacy sensitive information, then we can also start to think about actually actively sharing full QLog data sets or individual QLogs for additional troubleshooting, which of course leads to a whole bunch of new issues that might be interesting to discuss. So final slide. To summarize, we hope that eventually maybe QLog can grow into a separate working group if it shows that it can be done, if it can be done in a protocol agnostic fashion, which at this point isn't even clear yet, and that new working group will help their protocols to adopt. For now, we're starting this in the Quick working group mainly because of practical and historical considerations. So if you have any interest in this, please come and join us there in the next couple of months. Or join us on the separate GitHub and the separate mailing lists. And of course, I would like to listen to your questions and your feedback now as well. So thanks.
And I see an AD in the queue. Martin, go ahead.
Yes, thanks, Robin. Just to be crystal clear about the action items, I think come out of this as, you know, this core group is basically a community of proponents for a bunch of protocols. I would first of all encourage all of you to think about the applicability of this to your protocol, particularly if it runs over some sort of crypto like SCTP over DTLS or what have you. Secondly, if you think about how to apply this to your protocols, you may have some input into the main schema. And number one, you'll probably have to come to Quick to participate in that discussion. But if we see a lot of immediate interest in applying this to more protocols, we might take that and bring it to another venue for the core schema, not the Quick specific events, but the core schema. So that would be very useful input quickly if there's a lot of immediate interest in this. but we're not going to wait forever because we want to move this forward. And Quick is a venue where there's obviously is an interest. Of course, that is a follow-on. You can do your own draft in whatever working group is appropriate. This one for a bunch of protocols, obviously, using the base schema and then applying the events relative to your protocol. So I encourage really a lot of people here to start thinking about this and seeing if they can start thinking about how to apply and where and what they need to do in relatively short order. Thanks.
Okay, Phil, go ahead, and then we're going to close the mic lines and move on.
Yeah, I was just going to quickly say that I think that keeping it in Quick for the time being is a good thing. And if we spin it out to a working group, we might want to look a bit further and look into how you actually manage the Quick server, not just the output, but how you apply feedback. So I think it probably is better placed in a different context, but not one that we should be looking at now.
Okay, and with that, thank you very much. And we're going to move on to last one of the session. Let me make sure, oh boy, make sure I click in the right place and we'll get the right material up. Jonathan, how do you want to handle this? Do you want to go through the slides, or do you want to pick up where MapRG left off?
I think we just pick up where we left off. If anyone has questions, we should try to answer those, and then go on to.
Is there a particular slide I ought to put? Is there a particular slide I ought to put up to do that?
Well, it's a question of what people have questions about. I have a different slide deck for my talk.
So Jonathan, Peter, I wondered how much of the data you've gathered would be applicable to other networks. How transferable are the results you have here to other network deployments? Do we need more data? Have we got enough? How big are the data sets really?
Well, obviously this is only one vantage point. More data would be nice from other vantage points. And we have a script that can probably be adapted to other vantage points to collect the same sort of data. Pete knows more about the script.
Is the script available? Is it something we can just use?
Yes,
I like data, by the way. So data is wonderful, and it's really good to see data. Peter?
Yes, it is. There is a link to the repo, and it's just a script that can run on any Linux router. We used it up to a /16 subnet, but there's 800 some odd IPs. I'm not sure how far it can scale, but it's certainly beyond this. But yeah, we need to collect more data. This was collected over a fairly long time, 3 weeks, but 800 some IPs isn't, is a relatively small installation.
And probably the unique thing here is that we have a distinction between paths where we know there's an AQM and a larger number of paths where we know that there isn't an AQM within the ISP. Okay, if there aren't any more questions, perhaps I should go on to my talk.
Okay, I don't think those slides. All right. Well, let's just share the screen. You saw the guidance I sent you on what to try to cover. Okay. Oh, hang on. I have to stop sharing my screen in order to allow you to share. There we go.
Okay, and then I will switch this over to...
To some extent, this is a warm-up for the fun we're going to have on Wednesday.
Oh, I'm sure. Here it is. And
be gentle,
I
please.
will... Okay, so I'm Jonathan Morton, and I'm here to talk about the implications of some measurements that my colleague Pete Heiss talked about in the MapRG session a little while ago. First, I think I need to lay out some background principles. As engineers, we must be aware of the risks associated with anything we create. And aerospace engineers must take this extra seriously as they deal in safety of life risks, and they have developed a model for this. We internet engineers have it relatively easy, as the internet offers a best effort service which is not intended for applications where safety of life is at stake. The worst effects are therefore mostly economic in nature. We quantify a particular risk as the product of the likelihood or frequency that it occurs by the severity of the expected consequences. This means that equivalent risks might have different severities balanced by inversely differing likelihoods. The question of how much risk is acceptable depends on who incurs the consequences. In the lab, we can deliberately induce a particular failure mode and observe the consequences, and thereby establish the severity of a risk. To determine the likelihood, we must look at the real world to see how often the circumstances likely to trigger that failure mode will arise. Now, I'm not going to apply the aerospace risk model to the internet. That would be absurd. But if, for example, a systemic congestion collapse event occurred, or the root DNS servers all went down at once, that would be a catastrophic level event in internet terms. And that's why those servers are managed by a decidedly paranoid and very international group of trustees. At the opposite end of the scale, a single packet loss is something that internet protocols can usually recover from very quickly, so would be classed as trivial. It's still desirable to minimize such things, but they can be tolerated pretty well up to a point. We haven't had a systemic congestion collapse since the 1980s. Because effective congestion control is required by current internet standards as published in RFCs. Serious failure events do occur occasionally, and we hear about them in the news. Sometimes just the tech press, but sometimes the mainstream press picks it up as well. For the most part, we are concerned with avoiding major category events by design and reducing the prevalence of minor events. The tolerable level of risk is strongly influenced by exactly who it is that incurs the risk. If you're actually involved in the activity generating the risk, then you know what to expect and you have an easy way to stop the activity or to direct it away from yourself, perhaps even subconsciously avoiding other activities which you expect will interact badly with it. An interested observer might not know so much of the details of what's going on, but is at least paying attention. You might guess that a novel disruption event that you experience might be linked to this particular activity, and be able to inquire into whether that is true, and indirectly cause the activity to stop if necessary. But an innocent bystander might be affected by the risk, but have no idea of its existence. They would have no way to troubleshoot it, no contact point to have the activity shut down. So clearly the level of risk that innocent bystanders may incur is much less than for the other two categories. In short, we must avoid externalizing the risk. And in previous sessions, we have documented lab tests that mostly exercise one easily predictable failure mode of L4S, namely that it routinely squashes conventional TCP traffic that competes with it, whether ECN capable or not, in the same conventional AQM instance at a bottleneck. This is a serious impairment of an entire, rather widespread class of traffic, so it falls into a major category event. There has been some dispute from the L4S team over how likely or frequent such conditions are. At first, the focus was on single queue AQMs with ECN enabled, which appear to be uncommon compared to flow-aware AQMs. But then we realized that flow-aware mechanisms are defeated by encrypted tunnels, and that L4S in conventional traffic can share a tunnel and thus be indistinguishable by a flow-aware AQM, in particular the ubiquitous FQ-CODEL. Just as a reminder of how much harm is caused, a single L4S flow represented by TCP Prague forces a competing cubic flow to collapse to less than 1/10 of the fair share rate of our standard link. That's for long-running flows. But even on short flows, such as a crude simulation of web traffic, flow completion time is quadrupled with TCP Prague background relative to an equivalent cubic background. We'll be happy to discuss the specifics of this test offline or in the questions afterwards. Using the new harm metric introduced at the last IETF meeting, we see upwards of 0.85 harm inflicted by Prague on cubic, where cubic inflicts only about 0.5 harm on itself. 0.85 is a nasty figure. Now, if this almost never occurred in practice, then perhaps it could be overlooked. The only way to find that out is to look. So, we collected some anonymized data from a small ISP and looked carefully for firm evidence of ACN and AQM activity. We were able to distinguish activity on TCP flows that negotiated ECN support from those that did not, and look for CE marks and ECE flags, which are usually a pretty clear sign of an AQM on the path. Only a small proportion of TCP flows negotiated ECN support, but they were spread over a large fraction of the ISP's subscribers. This seems consistent with many subscribers having both Apple and non-Apple devices in the same household, and mostly using the non-Apple ones for internet traffic. We can only easily observe AQMs on ECT flows that drive an AQM bottleneck to saturation. So this small proportion of ECT flows was less than ideal. But we were able to observe AQM activity on 60% of paths that had a known AQM internal to the ISP, and on 10% of paths that did not. This latter proportion is clearly higher than the 5% threshold I recall was suggested on the list some time ago. It's also clearly higher than the rate of ECN negotiation by client endpoints. So, here is a serious question facing this working group. Given a major severity risk that could show up on 10% of paths at least several times a month, is that acceptable to inflict on innocent bystanders in particular? I would say not, but I'm only one voice. And let me be clear. Existing networks and their users are innocent bystanders. They do not know anything whatsoever about L4S, and most of them would not care even if explained. This ISP in particular has a very long equipment replacement cycle. Some of it dates from 15 years ago when they first set up. And that is one reason why only some of the internal paths have FQ-CODEL. But even if other ISPs upgrade more quickly, their cast-offs will often go to the less prosperous parts of the world for a second, probably much longer life. If we started eliminating them today, RFC 3168 AQMs would still be around for decades. What's more, a user who notices a problem can't evade it merely by disabling ECN on his own traffic. Not ECT traffic is just as affected. Only the AQM needs to support ECN to trigger the effect. The L4S traffic could involve a completely different device, such as a games console or a set-top box, which the user cannot reconfigure.
Let's see.
So rather than belabor the point further, I'll just leave this slide up as a summary and ask for questions.
And we are basically at time. So I think this is a good place to stop. We could take a very brief question now. Definitely should let Bob in, since I think he's got some comments. But I think a lot of this is for people to think about for the next session. Bob, go ahead.
Hi there, can you hear me?
Yes.
Yep. I appreciate, Jonathan, that you're trying to prove a point here. What seems fairly sort of incongruous to me is that this risk analysis that you talk about here was never done when FQ was deployed, and you're talking about, you haven't told us what the risk of a VPN having flows within it crushed by FQ is, without anything to do with L4S anyway.
You're breaking up here. I'm having a very hard time understanding you.
Right. Sorry.
Well, let me refer back to an earlier slide. So a major severity harm is where the service quality is seriously impaired for example, a class of traffic. Whereas a minor level severity would be a moderate, sustained, localized impact on service quality. Wouldn't it be reasonable to suppose that the impact of a max-min fairness enforcement would be limited to minor?
No, because you can have any number of flows in a VPN that FQ puts all into one queue. And so there's no limit how much damage FQ does. And then you seem to be not looking at it at all, and then saying, when you add over to this, suddenly it's really serious when it was already serious.
I don't know about other people, but I cannot make sense out of what you're saying. I think what we need to do is call time on this and take further discussion of the list, and there'll be an opportunity to dig into this further on Wednesday.
Okay, I can get behind that.
I think with that,
and maybe Bob can troubleshoot his audio in the process.
Yeah, If Bob's audio is this bad on Wednesday, we're gonna have serious problems. So I hope we can figure out what's going on there. Yeah,
I
just
just
got a
stopped
whole
the
lot
screen
better.
share, and it seems to solve the problem. Do I repeat it all? I don't know. I was just saying I'd like to see. I mean, the analysis of how much of the problem was originally there, or is originally there, because L4S doesn't exist yet on these networks. With these VPNs.
Yeah, and your audio is going downhill again. I think you're asking how much of the problem exists completely absent L4S, and I think on that note, we probably ought to wind up the meeting. All right, I believe we're done. Thank you all very much. We'll see you all on Wednesday.
All right, see you then.